Hello, welcome everyone. Now we are going to solve A, C equivalence K is equals to Q total over V total. Because Q total is given, V total is given. Q total is 3, 4, 5, 6 times 10 to the power of minus 6 over V total is 48. So the result will be 72 microfarad. And we know also C equivalence K is equals to C1K plus C2. And from there I can calculate the C1K. If I want the C1K by using formula of dielectric constant, I can calculate the dielectric constant also. So C equivalence is equals to C1K plus C2. C equivalence I calculated 72 microfarad is equals to C1K plus C2. C2 is 24 microfarad. So C1K will be, when we subtract it, 48 microfarad. And we know the formula C1K is equals to K times C1. So K is equals C1K over C1. And I calculate C1K and I know the C1, so I can calculate the K. So K is equals to C1K is 48 microfarad over C1 is equals to 16 microfarad. So the result will be K is equals 3. This is the solution of A. Solution of P, it has two parts. Before inserting dielectric, after inserting dielectric. First of all, I'm going to calculate before inserting dielectric charge. Q1 is equals to C1 times V1. Q is equals to C times V. Charge is equals to capacitance times potential difference. First charge is equals to first capacitance times first potential difference. So it will be first capacitor charge before inserting dielectric, it's 16 times 10 to the power of minus 6 times potential difference, because they are parallel, so potential difference equals to total potential difference, so it will be 48. So the result will be 768 times 10 to the power of minus 6 coulomb. And Q2 will be what? Q2, of course, C2 times V2. And C2 is 24 times 10 to the power of minus 6 times V2 also equals to total potential difference 48. So the result will be 1152 times 10 to the power of minus 6 coulomb. And this is the before inserting dielectric charge of each capacitor's plate. And after inserting dielectric, Q1K, because we insert a dielectric just to Q1, so it will be C1K times V1, or we can write it V1K. It's equals to, what's the C1K? We calculate it as a 48 microfarad. That means 48 times 10 to minus 6 times V1. What's the V1? It says battery is still connected, so potential difference constant. Potential difference does not change. So if it does not change, potential difference equals to previous one. So 48. The result will be 2304 microcoulomb. Instead of 10 to minus 6, I substitute, I rewrite it as a micro. So Q2 will be C2 times V2. Second capacitance of the capacitor and second potential difference of the capacitor. And it will be C2 means it does not change because there is no inserting dielectric in it. 24 times 10 to the power of minus 6 times potential difference again 48. So the result will be 1152. You can write it micro or 10 to minus 6. Which one do you prefer? You can write it as a micro. It will be micro coulomb. Thanks for listening.